Today, we are going to look at the elements of light. What is light? Light is a magnetic radiation that produces a sense of sight. Now, where do we get this light from? The main source of light is the sun. The light comes from the sun. Then you can also get light in your house through a lamp, candle, or torch. Everything in this creation is visible to us because of the light. So, how do you see this? Because in the darkness we do not see the light. Children often wonder why we do not see objects in the dark but only in the light. Suppose we were to go into a dark room. What will we take with us? When we go into a dark room, we take a torch or a lamp. We see a lot of light in that room, but we don't need that day. So, whose light is there? Of the sun. Even when we go out at the night, we carry a torch or lamp. But on a full moonlight night, most of us get light at night. But in a dark room, you can't see the moonlight, so you can't see anything. How do you see this thing now? Why does it look? This we will see today. Going to show you some experiments for that. What's going on? The rays of light always go in straight line. Now, what are the consequences of going in a straight line? And what are the consequences if interrupted? Let's see. Then, there is a small experiment in which light rays travel in a straight line. Let's see. It's in your home, when it is not in use, they spoil and we throw them in the trash. Now, let's see how to use this CD. You will notice that this is a wooden bar. This wooden bar has grooves at equal distance. The blades have given these notches, and I put this CD in the notch. This is how you want to load all the CDs. Now, this CD already has a hole. That means you don't have to punch a hole. But if you bring a cardboard from the market, you have to cut that cardboard. The hole has to be drilled. He has to make a stand. It has to make a stand to stand upright. This is how they show you in your school to experiment with light. Show that the light ray goes in a straight line. But you have to work hard to experiment with cardboard. And it is costly also. But what did you do here? Here, took a wooden bar and at a distance of about 3 inches, we used to make a notch on the strip. Created this notch. Now after making this notch, let's say if it feels loose, take a strip of paper. I wanted to put it in a strip of paper with this CD. You can make as many notches as you want and fit such a CD. You can see these holes in a straight line. There is no need to work hard for it. Take a candle, put this candle here, light it with a matchbox. When you look through this hole, this candle. In the meantime, we used to bend this CD a bit. Then you will not see the flame of the candle because this light ray comes through this hole, which is the CD in the middle. That ray of light was blocked in that CD. From this, we can say that the ray of light travels in a straight line. You can easily do this simple and easy experiment. Let us now look at another experiment of this nature. Now, let's do this experiment as shown in your textbook. It is made up of cardboard and I'm going to put over this. This is how you can move back and forth. This is the measurement you have to take accurately. Without it, experiment will not be successful. I turn on the light from here. After hitting the light from here, you will see an image. See the image here. Laser can also show that the ray of light now travels in a straight line. Next, we will see the experiment. As I said earlier, you see an object if it is visible only in the light and not in the dark. Why is that? Let's see. There will be a ray of sun or an light source like candle, lamp, flashlight. When its light falls on an object, it is reflected and goes into our eye. Of water. Adding milk to it, it increases the density of this water. Small particles of milk are visible in this water. Now I drop this beam on the water. Do you see the water red now? This is called radiation of light. Look at the radiation of light. Do you know the speed of sand and dust particles in the atmosphere when the rays coming from the sun reach the earth? Do you know how long it takes? It takes 7 minutes and 45 seconds for the sun to reach the earth. Light travels a distance of 3 lakh kilometers in a second. Then, even after crossing such a distance, the ray of light reaches us in 7 minutes and 45 seconds. Then, there are numerous dust particles, sand particles, as well as water vapors in the atmosphere. As the rays come from the sun to us, light rays reach us through this barrier. We will see it in this experiment. It is also called scattering of light. Adding milk to this water increases density. Rays of light were scattered, and if you leave a ray in this water, you don't see the light in it because this water is clean. But if we leave a ray in the milky water, we see light spread because there are particles in this water, so that the light changes its path. But even if the light changes path due to the particles, it goes in the straight line again. If the path of light is blocked for some reason, it is reflected from that place and goes in a straight line again. Also, after you hit the small ears of this milk with laser beam, that ray hit those small particles and the light rays was scattered. And so we see that is scattered, that is radiated by light. This is a natural phenomenon and this is called the Tyndall effect because the name of the scientist who discovered it was John Tyndall. This is why the experiment was known as Tyndall effect. You need two glasses to do these experiments. Pour pure water in a glass that does not contain any dust. So I used to take a bottle of water from Bisleri. If you take a tap water, the water already contains different salts. So this experiment will not be successful. And take a plain water in the another glass. Add 1 to 3 drops of milk. When taking glass, its outer surface should be smooth. You will also find such a laser in a toy store. When the laser first hits a glass of clear water, you can see the rays pass through. This laser does not want to hit anyone in the eye or misuse it elsewhere. It is also used as a pointer in your school or to show the stars that are in the sky. After you hit the laser on the other glass, the light radiated in the glass. Look, it is not visible on the wall. But when I hit the laser on the clear glass, you will see its image on the wall. Let us now see an experiment on the reflection of light. Now I have a laser. This is a flat mirror in front of it. Through this flat mirror, we will see how light is reflected. After I hit the laser beam here, you see me throwing rangoli here. After I hit the laser mirror, it is reflected and looks here. Now you can see it on the wall also. For this, we took a laser as well as a flat mirror and place it at right angles. The beam of laser, what you hit on the mirror, then there is a ray of the same. It is reflected and we see it moving forward. Let me show you again how this ray is reflected. Now pay attention here. Do you see the light here? You see the rays coming from behind. This is called reflection of light. You will find the same study in class 9th and 10th. From the fact that the ray of light travels in a straight line. You can see in the geometry that the rays are in a straight line. They never take turns. This is what we call the ray of light. When you go to the salon to cut your hair, there is a mirror on the back. There are two mirrors in the salon. One is in front of you and other one is behind you. In the front mirror, you can see the face and also the hair on the back. It reflects light so you can see your back here in the front mirror. Now we will see the refraction of light. I have a pencil in my hand. I am going to put this pencil in this glass. Is this pencil straight or crooked? I put a straight pencil in this water. If you look at with a pencil from upside, you will see it a straight. Now if you look at the front, it will look slanted and it will look thick. This is called refraction of light. Refraction we see in the many places. When you go to the beach and your feet are in the water, you feel that your feet are low. This is called refraction of light. What color do you always see the sky? That is blue. Here we have to see why the sky looks blue. The rays of light reach us. This ray of light is white. But Newton proved in 1869 that 7 colors can be seen from one prism. If you look in this direction, you will see different colors. In it, you will see the 7 colors of the rainbow. Newton said that if we analyze light rays, we see 7 colors. This is called Newton's plate. You see 7 colors on this CD. Now, when I rotate this CD, you will see only one color on it. It is white. Now, one side of the CD was lined with a 7 colored paper. The colors were red, orange, yellow, green, blue, pigeon and purple. Don't take black color. Also, a glass prism has 4 sides. If you emit a ray of light from it, you will see 7 colors on the other side. This is called light separation. Even in the rainy season, when it is raining in the evening, when there are clouds and the sun is in the west, we often see a rainbow in the east. What was happening then? The sun's rays fall on that drop of water, then we see that a rainbow is formed out of it. When the rays of light fall, when it also rains, the sun's rays fall on the water and act like a prism, and its image we see to the east. Therefore, Newton's theory is that the ray of light is not white but 7 colors. It has 7 colors and the curvature of the 7 colors is more or less. Also, when the sun rises and sets, the sky looks orange, and other times you see the sky blue. Whenever the ray come out, the curvature of the rays means that the red color is less and the blue color is more scattered. The blue color is more scattered, that's why we can see the sky is blue. Then there are dust particles, water particles in the atmosphere. The blue color is spread more on those particles because the blue curvature is higher. The sky is void. When light rays spread through the cavity, you see the sky turning blue. When Dr. C.V. Raman thought that if the sky is blue, then why the sea water looks blue? Because the water has no color, no taste, no shape. Then notice why the sea water looks blue. And on February 28, 1928, he published research showing that the sea was given a blue color by the sky. The image of the sky falls into the sea and then the blue color is received by the water. This research is called Raman effect. Therefore, this light research was recognized globally. C.V. Raman was honored with the Nobel Prize. That is why we celebrate this day as Indian Science Day. That's how we saw this light topic in our science workshop.